Now you should be able to hear me. Okay, right. And we can... in the background. Yep, that's better. Okay, so really this is just a quick one that I wanted to do to show off what I've been working on with the little simple web browser that we're making for the Mega 65. So the idea of this is not to have a full JavaScript and CSS kind of browser, because that's not really going to work very well on this kind of hardware. But what we can do is make something which is really nice and fast and responsive, and can make use of the Mega 65 graphics. And instead of having the format of the page is separate from the page itself, we actually just have it all at once. So we don't separate or rather the separation of form and semantics is actually done on the server, where we actually pre-process just simple markdown files, and I'll show you what they look like. Oh, sorry. Righto. Is that hopefully a little bit better now? I think my mic's a little bit quiet and the music is a bit loud. The level's a little bit better now, I hope. And hopefully there's not too much latency. It's always a bit laggy streaming from here in Australia, which is a bit annoying, but such is the way that things are. Just knock it down a little bit, because I think the problem is that I'm... Okay, cool. Excellent. So I'll start all that description again. So what... really, this is just a quick stream to show what we've been doing on a simple browser for the Mega 65. And in creating that browser, we're not out to make a CSS and JavaScript beast. We're out to make something which actually, in the true kind of Commodore 64 spirit, something that is small and lean and efficient, and graphically can look quite nice as well. So we've separated the web normally separates semantics and formatting by using HTTP and CSS and things, so that you can have the content described in a flexible kind of way. But on the Mega 65, the hardware is constant, so we can actually just make pages that are effectively pre-rendered, because network speed's not really a big drama anymore in comparison. So I have a program that takes markdown files and converts those into what I'm calling H65 format, so hypertext 65. And that's really actually basically an image of the chip RAM on the Mega 65 that needs to be loaded in order to actually display the page. So we can do different graphics modes. You can supply graphics mode information in the header for an H65 page. So you can set whether it's 640 by 400, 320 by 200 or something else. Text mode, bitmap mode, bitplane mode if you really want to as well. And set the pages up this way. So this is probably best actually explained further by me actually demonstrating things. So we've got Mega 65 there, so I'm just going to load it. So at the moment this is just a simple tiny program. Again, the graphics actually all get loaded in as part of the page into chip RAM. And so this is pretty straightforward. So with DHCP config and everything. And once the DHCP config was done, hopefully you can see that that was actually fairly swift at loading the actual page. So this is indeed just a quite simple bit of markdown that's produced what we can see here. We have a nice image, we've got text, we've got bold, we've got headings, we've got links, and I'm not sure, you can probably see, you can see the mouse cursor at the moment, so it's kind of flashing white and light red, but it's visible the whole time, so that means we're not on a link. If we're on a link, I come down here to fetch, we can see that it flashes light blue, dark blue, and of course our background on this page is dark blue, so that effectively it's disappearing part of the time. If I do it over the image, which is also clickable, you can kind of see there a little bit better that it's doing that. Now this link in the image actually is to the same page, but we can click on it and it loads the page up again. And so this page is the better part of 100 kilobytes. I'm directly connected on the LAN, so Mega 65 is on the LAN directly into my laptop, which is running a DHCP server at the moment, so it's having some dramas with the Ethernet over power adapter, but we might even muck about a little bit with that in a moment and go back onto the regular network over the wireless and things. So again, we show going to different pages. So here, so the moment this browser is just called Fetch, for want of a better name. If anyone has an idea of a better name, let me know. We'd love to hear. And okay, so this is a bit of a boring page. It doesn't have anything on there. We can find out more about Megawatt as well, or we can go back. So let's click on the Megawatt page. Okay, this page needs to be written. And again, we've got the nice Mega 65 logo, in this case not visible. Ooh, yeah, sorry, sure, I can, the easiest will be for me to decrease, oh actually no, hang on, I can make me a bit louder. Okay, hopefully that will be a bit better now. Because yeah, I think the minus 30 dB for the music, so that should be okay. But let me know if there's anything that you kind of couldn't hear and understand there. And so anyway, so we have a link here, we can go back and it will pull up. And so again, we can see that, you know, the page load time is not particularly slow. It supports the mouse, so I've got a Dell mouse on here at the moment with a it's my birthday present that took a while to come, a Mouster. Love it, and this just works. You configure it as a 1351 C64 mouse, pop it into port 1, same as you would use it for GEOS as well, and then I can use this quite reasonable $80 cheap and cheery mouse, and as you can see, it's working quite nicely. So at the moment, so far, all these pages have fit on one screen, but we're actually not limited to that. If we go here, we have a Lorem Ipsum page that is purposely longer than a page, and again, I'm just using the mouse, and you can just scroll quite naturally, and you can see it's nice pixel by pixel smooth scrolling as well. I'd love to get the Mouster to have support for the mouse wheel. That would make me very happy. And I just realized, of course, I was showing you the mouse and the Mouster without actually putting the camera on there to show you. So there's the Mouster, it's just a little tiny thing, and you can get those from Retro Hacks online. Thoroughly recommend it. They're just a joy to use with the Mega 65. And again, we can go back to the index page, and so we can click and load pages to our heart's content. To get to this point has been 2 or 3 days of pretty hard work. The TCP engine, the Ethernet controller, there's been a whole bunch of things that have had fascinating interrelated and interconnected bugs. And yeah, it's really nice to get that working now. And now I'll show you what the page input format looks like. If I change my view here a little bit, it's actually some of the source code for the browser. We want to go to index.md. So this is literally the file that generates that logo. So we could, for example, if we wanted to, let's make instead of having it link to the index, we'll link to a new page called devkit.h65, which we'll make. Just got this really crusty script that I'm using at the moment. I'm going to improve this markdown to H65 program so that you can actually just give it, like star.md, and it will produce the H65 files from it. But we haven't got that far yet. So we'll say devkit.md, devkit.h65. So that will create that. And we need devkit.md, the Mega 65 development kit, dev kit, and we'll put the image in. This time we'll remove the link. We'll just leave it just as an image because we don't really need it to go anywhere. Yeah, thanks, Tager. We're actually really happy with what we've created here. This is going to be a really fun way to do stuff with the Mega 65. The Mega 65 development kits were released in 2020 to enable early adopters to begin to write software tools for the Mega 65, as well as to have fun and share the good news about the Mega 65. Now we should make part of that bold. Let's put the double star around it, normal kind of markdown. Now, at the moment, we don't have a navigation system in here, so we can't. There's no back button or anything. That you can press R to reload a page, but that's all that will work. So we'll just make this really cheesy, simple page. I will then run the program that regenerates the page, and actually it's set to restart the Mega 65, but in fact we don't need to restart the Mega 65 because again we're loading pages off of a server. So I might even do a quick example of that. No, this is one bug that I've still got left, where occasionally the TCP connection process balks for some reason. I'm not sure why. I need to investigate it. And I can hit R to reload, and in theory that should reload it, but it's not. I can hit run stop. And so there's something kind of funny going on there. So I'll... Oops. Actually, so when I hit reload, it probably was going to work. So the web server I'm using here is this tiny little Python thing, and it's fully single-threaded, and it requires the previous socket to close before it will open the next one. So if I'd hit Control-C on it, it probably would have worked. But anyway, so here's our... this should now go to the dev kit page, and it does. Now why don't we have the image? What have I screwed up in the image? Oh, and I've put the wrong text in there, so that's a bit balked. Oh, we've hit another bug there, but such is life. If we go back, so the formatting of that is right. I'm going to put a link on that just in case there's something funny where yeah, okay, right, so these are around the wrong way. Index.h65. And let's go back to Mega 65 and start the thing. So I'll change a page in a moment while the thing is actually running. Is HTTPS also working, or additional work required for that? There is no HTTPS in this. The browser code, I'll actually go through it in a minute because it's actually remarkably simple. What I tried to do is come up with the most gobsmackingly simple thing that you can possibly imagine that would create a browser-like experience. And so, yeah, it just does a bare HTTP. An SSL library would be probably hundreds of kilobytes. We'd need to, I think it's going to be possible to make one, but that's going to require some significant effort, probably in assembly, to make a decent SSL library. But hey, we're after a 1990 style computer where HTTP wasn't even around. Certainly not HTTPS. But there's actually other ways that you can authenticate pages without needing to do all of the crazy SSL. You could actually have a digital signature embedded in the pages that actually says that it's a page from such and such a date. Pardon me with the... more the point, you could actually have an MD5 sum or a SHA-2 56 sum in the link that goes to the page, and then you sum the page to see if the page matches the link. Totally understand asking, and it would be great to if we could have a way to do HTTPS, and it's in the back of my mind. But anyway, so we're back here now, so we should be able to just make sure we can, again, we can load pages, and that's all working just fine. Let's click on that, and we should. Right, now we've got the thing here. Now we've got the image, which is great, and the image is going to, again, I've just got it to the main page. So in fact, actually, we can now jump between these two pages by clicking on the image, which is a little bit fun. And we should be able to click, and go back to the index page. So we can go to the dev kit page, and we can go back to the index page. And again, you can see that the load time, so this is a page with graphics, right? And it's not too bad, given that we're on a machine with a 40 megahertz CPU and a TCP receive buffer of 2 kilobytes. So we don't have a big TCP. Hey, Heinz! Yeah, that's right. Yeah, reinvent the internet with Mega 65. Yeah, we'll try. So it's pretty fun. So actually, if any of you, if you want to in the chat, if you want to paste some markdown that you would like me to stick in a page, and even throw me, even via the Discord server, if you throw me a PNG, a 256 color PNG, we have got color sampling down to 256 colors in the converter, but it's currently horrible because I really just cropped this up together quite quickly. But if someone wants to cook up some markdown with an image or something in it, we can have multiple images, but again, the moment the color sampling is monumentally stupid, and so everything will share the same 256 color palette, and it doesn't do the kind of the color averaging thing. It's basically just going, okay, the color which appears the least, how can I move that to a color that's closer, to the closest color rather for it. So it's just eliminating additional colors beyond 256, but we can totally have multiple images in there, and we do all of the nice Mega 65 pardon me, the VIC4 funky trick where, because the images is drawn using tiles, if we display the same image more than once, the deduplication of the tiles means that it doesn't actually take any more space. So I'm going to save this page. I'm not going to reload the browser, so we'll see that the browser will still be there, on that page when we come back. I'm going to MD to h65 devkit.md devkit.h65. Oops, MD has more D's in it than that. Right. So it's created it. And we can actually see, so this is me running the conversion tool, right? So it's finding the image, it's finding the links, it's deduplicating the links as well so that they take less space. It's telling us what it's doing, so it's writing out the tiles. So if we now have a look at devkit.h65, so we can see that this is about 120k. So when that page is loading, right, it's doing that 120k in that little bit of time that we're seeing there. So the h65 file has 128 byte header. Oh, sorry, and someone is Integra is asking, page loaders are very fast, doing it all local. Would it also be about that speed fetching data from a remote server? That will be interesting to see. So the biggest challenge we're going to have for loading speed over the internet is that we're going to start suffering bandwidth delay product. So this is computer network jargon for the fact that however many packets you have in transit and the latency of a link will affect the throughput that you can get. So here in Australia, I can end up with 330 millisecond pings to servers in Europe, and so the TCP buffer we have on this at the moment is about 2 kilobytes. I can probably push it to 3 kilobytes. And so if we kept that more or less full, that's 3 kilobytes every about 300 milliseconds. So we're going to only get about 9 to 10 kilobytes a second loading pages over the internet if we do it that way. Now, we can get a bit clever pants. I can make it lie about its receive buffer size so that if packets are coming in order, it can progressively lie and say that its receive window is larger, so that the other end will send a whole pile of packets that we hope will arrive in order and can be reassembled and put back together. And only if it starts getting packets out of order would it then need to drop that back down, to the real 2 or 3 kilobytes that it has. So that will be interesting to see. I'm actually quite looking forward to seeing how much we can optimize it, because we should be able to get page loading speeds that are not dissimilar to what we're getting over the LAN. It will be a little bit slower because it just has to be. The TCP three-way handshake will take a bit longer and all of those sorts of things, and we have to do DNS lookups. That will also take a bit of time, because when I'm referencing an IP address directly, we don't need to. Anyway, so here is the header for the H65 file. So there's a magic bytes here, H65 and an FF. The parser in the browser, which I'll show soon enough, basically just looks for that. And then we've got version information. We've got information about how many columns the text is and things. They're all kind of defined, and the bulk of the bytes at the moment are currently not used in that header. Then we have address chunks with the size of the block, and then the data. So this is the palette is following in here, and then after that block finishes, we have another definition for the next block that just tells it what address it's allowed to be. So this is the next one here, and so this is saying at address 12000, so in bank 1 at 2000, and it's 4C E0 bytes long. That's actually where the page text goes, and you can see the page text here. So MD to H65 by default will create pages that run in 16-bit text mode on the Mega 65. So we can see that there's 2 bytes for every thing there. Hey Amok, welcome along. When we get further down to where the image is, you can see actually down here, here's where the image is. We have other stuff in the second byte for those. So instead of 00, we've got 10, which is telling it that it's going to be a higher tile number and things. So Heinz, you're asking, so would this end into an online manual, transforming LaTeX into H65 files. Yes, actually, there are tools to convert LaTeX into Markdown. So then from Markdown, we can go to H65. It would be great to actually render the Mega 65 manual into a form that you can access from on the Mega 65. We would love to do that, and it wouldn't be very hard to do. And again, part of the design of doing it this way, of using regular HTTP, is that anyone running a web server can actually now host Mega 65 pages. So that you don't have to do anything kind of special. You can do it on normal hosting, and it will just work. So yeah, really looking forward to that as people do things. So even now, if any of you have a web server and would like to host some content for us to start playing around with and start testing the performance over remote networks and things, we can totally start doing that. But anyway, so again, just talking about the file format, there's really nothing else to show. It's just these different pieces of the file that do that. The font that you see in the pages is also included in there. So this is actually a ASCII C64 looking character set, so that we can have pages written in regular ASCII instead of having to write them in PETSCII. But also, if you wanted to make a PETSCII gallery site, you could just use the regular font out of ROM and display it, and it will look really nice. Again, you're basically just loading chip RAM contents in and telling the Mega 65 how it needs to be displayed. It's super simple. So Tago, you're talking about having something on the file host where you can create pages in a way that can be presented. Absolutely. And so again, because we already have the nice little conversion tool that can do Markdown, that's probably an easy intermediate format for your tools to generate. Or we could hack something up that generates H65 directly. So what I haven't shown here, and because we haven't implemented it yet, but again, because we're doing this chip RAM approach, is that we could take, for example, the proportional font rendering code that we used in Megawatt, and use that to actually make pages that have fonts of different sizes and with nice kerning and anti-alias text and all of that, because anything that you can make the Mega 65's VIC4 display as a static screen, raster rewrite buffer affects the whole lot, we can totally do here as well. We might have a think in the future as well about how we can have some simple animation kind of stuff. We need to be pretty careful as we think about scripting kind of ideas from a security perspective and just a constraint perspective. But we could potentially have pages that actually have a routine on them that that gets called either as a raster interrupt or something like that, to make the pages more interactive as we kind of progress our way down. But yeah, so I promised I was going to show you the source code, because it is just to give you an idea as to how, as I say, my goal was to make the simplest thing possible, partly because CC65, the C compiler we're using at the moment, it's great and I love it. I'm glad that we have it, but it doesn't produce very efficient 6502 code. On the flip side, it supports pretty much all standard C, so we can do a whole pile of stuff. But it's one source file plus the TCP/IP stack. It's 600 lines of pretty dull C, really, is the entire browser. So I can actually show you from the top everything that's in here. So we've got a bunch of includes. We have the mouse pointer. Sprite is defined in here, so that we copy that into place. A bunch of hash defines for indicating how the a page load has succeeded or not succeeded. Yep. So this is a bunch of flags that we pull out of the header. A disconnected flag so that we can keep track as to whether or not the TCP connection has dropped. This is our buffer for the TCP reception, so it's just at C000. CC65 uses from the top of the CFFF down as the C stack, so we can't use all 4 kilobytes. Currently, I think I'm using 2. I've said 2 kilobytes to the thing, but we could potentially do 3. and these two variables, last bytes and parse state, this is used for finding that H65FF thing, and then knowing what state we're in doing the parsing for that binary page format. This is the callback that the TCP/IP stack calls whenever an event happens on a socket, or on the socket, because you register a callback per socket. So when the connection gets made, we then send the buffer that we have pre-prepared in another function containing the HTTP request, and we take note that that's kind of where we're up to. If we get a disconnection, we set the disconnect flag that we showed earlier. So this is in Amok. This is in normal C using CC65. So kickc I wanted to use for this because it would produce much smaller code and will let us cram more features in, because I'm really running at the limit of what I can fit in memory with the TCP/IP stack and this browser at the moment. So this is totally standard C at the moment. kickc doesn't support unions, and our TCP/IP stack that we've grabbed, so it's based on one called WeIP, WEEIP, that uses unions in some quite nice ways. Like they have a data type that is a 32-bit int and two 16-bit ints and 4 bytes, and then it's kind of nice and efficient to access. And there's things like that kind of all through it. So it was a pain to try and to port. So I have asked Jesper if he would be able to add unions into kickc for us. So hopefully he'll say yes, and hopefully he'll be able to do that. And then we can move across to kickc for that, and that will then it will be faster again, and it will hopefully free up. My guess is close to half of the the odd 40 kilobytes or so of the program at the moment will be freed up and really let us put a bunch more interesting stuff in. Okay, so when data comes in, we display a full stop on the screen. So we always show the C64 40-column screen when we're loading a page, just because then I can do printf, and I can it's easy to show and do things. We go through the data, we look for the H65FF marker, and a little bit of just of magic to make the parser reasonably optimal here. Once we've got the header, we then just have the case statement for each byte as we read through, because again, this may not all come in one packet. Because it's TCP, it could come split over multiple packets, so we have to allow that, so the state machine allows for each byte to be read individually. And then once we've read the header, so the header is 128 bytes, we're ignoring all the bytes in between. Then we have the header blocks where we say what address we're loading to and how long. And once we have that, then we check whether the block is, if it's a 0 length block, that marks the end of the file. We don't allow you to overwrite low parts of memory. That would be naughty. So the browser should not be able to load a page down that updates the browser while it's running, because that would be called a remote code execution vulnerability. And if the block is more than 2 banks long, then we also just say no, this is not a good idea. And we probably need to put some extra checks in here as well, which we'll do in due course. So for example, so that you can't overwrite low memory by writing to the top of memory with a 2-bank kind of thing. And then once we're in one of these blocks, reading data, we then actually read all of the data out of the packet in one go, and we copy it into its intended location in memory, so that we're not wasting time going through this for loop for no good reason. And of course that makes a big difference to the performance of it. And so we update all the counters and things, and then we update our position in the parser. So that's what happens when we get data in there. Now, a couple of questions there. So Amok, you're asking, are there already C libraries to access the VIC4 or SIDS? There's some libraries that do some bits of that, but nowhere near as much as we would like to have. So if you're in the mood to code standard libraries to do nice things for people, you're going to make friends. and we're going to be very happy. So take a yeah, asking about playing audio files over the browser. Yeah, so we could totally add support for playing audio in there. I mean, the other thing that we will want to do is actually to have some kind of MIME type support in the browser, so that if it's not an H65 file, we can go, oh, it's a mod file. Right, we can load a mod player. It's a SID file, we can load a SID player. And do those sorts of things. Again, we have to think a little bit about the security, because you're effectively loading code down from the internet and running it at that point, and by definition with an internet connected C64, so to speak. So we need to think about some ways to look after that. Like we may end up with a hypervisor call that you can call that basically says, right, turn off all the storage, and only have a read-only D81 image, disable the Ethernet adapter, so that you can actually run a program in a sandbox like that. So yeah, okay. Dump bytes. Actually, we're not even using that anymore. I'm just going to remove that. Little routine just to switch to C64 40 column mode, so that when we're doing the page load, we can kind of show how that works. And then we have a routine here that prepares the network for first use. So this, again, we've set the 40 column screen, we set that light green on black text display. We're showing the user what their MAC address is, initializing the TCP/IP stack, scheduling the Ethernet interface monitoring task. We're saying that we don't have a DHCP configuration yet, that we're going to get one. Then we ask for DHCP autoconfig to start, and we have to wait until that's finished, until that DHCP configured flag gets set. We need to keep calling the task periodic. Now, this was the task periodic. Really, you would try and call in an interrupt in a normal kind of thing, but again, just for simplicity and everything, I'm actually just calling it in while loops in here. And we also update the mouse position so that the mouse becomes responsive even during the DHCP kind of process. And then we show the user what their IP address is, which is probably a bit of a moot point, because as soon as it's displayed, we return from the function and we go and clear the screen and show something else. So, speaking of the screen and displaying things, the scroll down routine lets us move the viewport in the page view, which assumes 640 by 400 resolution, based on the mouse position. So if you move the mouse 3 pixels off the bottom of the screen, it will try and move the screen down 3 pixels to match it up. And so we do that, and the way we do the scrolling, we just using VIC4 features here. So we set the screen offset to the line of the screen that we want to display, and we set the color RAM offset. So I should change this. Set screen color RAM offset address. And other than that, we just set the smooth scrolling we do by actually displaying one more line than the 50 that can fit on the screen. So we don't have to bring the borders in, like on the VIC2 you have to bring the borders in so that you can only see 24, because you're actually moving where the 25 rows get drawn. So we draw 51 rows so we can keep the full height of the screen. And again, like on the VIC2, we just use the VIC4 registers that let us do the arbitrary positioning of the screen to set that. And other than that, we're just computing the location to put it in. Other nice little thing up here, we wait for vertical blank before we do it, so that there isn't any tearing. And if we go back to here, we go to the Lorem Ipsum page, and if I scroll that, unless the transcoding is doing something terrible to us, you'll see that it never tears. It just jumps based on where the mouse thinks it needs to be, and I'm sure there's some bugs in there, but you just get this really nice, smooth, natural feeling to it that looks quite good. And before I put the VBlank interlock in there, it looked quite crustier So yeah, it's one of these nice little things, and it costs us 12 bytes or something to do that. Right, so that was the page scrolling piece. Then we've got the fetch page routine. So this is the routine that actually gets called to load a page and then to have it ready to display. So we get the host name, the port and the path. We say that we disconnected from the socket. Position 0, we scroll to the top of the page. We go to standard C64 screen colors, C64 40 column screen mode. We say that we're going to fetch the page. We prepare the HTTP request. So yeah, take it, the scroll up down, absolutely, like it's using it here, right? That we have that there, and with and using a just a bog standard mouse. It's really funny. It actually feels like it just feels really nice and responsive and really natural. And as you said, it's native. It doesn't feel that it's been tacked on rendered. It feels like the page is supposed to be there. And having the ability to show the graphics as well is just really kind of nice. And actually, one thing here you can actually see, while I think of it, is if the PNG supports transparency, the conversion tool preserves that and actually has the pixels transparent. So that's actually showing through to the background. If I go into matrix mode, set FFD3021, we'll change the screen background color to grey. And we can see now actually there's some aliasing just because of the way that the logo was created. But we can actually see that those, the picture is not a rectangle block. You can have arbitrary holes in it. And it would also be quite easy for us to support text flow around the images because that's all done server-side, pre-computed, right? So yeah, I'm actually really quite looking forward to improvements in that tool, whether it's myself that has time to do that or whether someone else has the time to do that. But yeah, it's already feeling like a really nice kind of thing. And so that again, the page can actually set the colors for the whole display as well. But anyway, going back to the code walkthrough, so we generate the HTTP request. So there's the the agent string to look out for in your web logs if you start mucking about. Because we're using CC65, it's a bit hard to have ASCII strings preloaded in there. So at the moment, it just means that we're wasting a few bytes and then having to munge that into ASCII from PETSCII. And that's also why we've got the case inverted, because PETSCII. We set the page load state and parse state. So we saw in that callback, right, how we're using those things. We then clear the memory regions that are available for the page to use. So in bank 1 at 2000, that's where the so more specifically from 12000 to 17FFF, so that's 24 kilobytes, is reserved for screen RAM. So if you have 80 column text in 16-bit text mode, it's 160 bytes per row. You've got 24K, so you're going to get, it's a couple of hundred lines or something I think you can have, which is probably enough for any page. If it's longer than that, split the page. And then from 18000 to 1F7FF, that's the area for the URLs and the bounding boxes for the links. So the URLs and links are all wired in as bounding boxes in the binary format. So again, this is actually really quick and easy. You'll see that, I'll show you the code very soon for how we work out which link we're on and to pull that out. And the strings are in there, and they're also deduplicated. So if you have quite long URLs, but there's a bunch of links that point to them, it won't take up more space in the file. So it's close to, it's 30 kilobytes actually that's available for bounding boxes and links. So again, you can have hundreds of links on a page potentially. Right, so then we do a DNS lookup on the host name. So I had to write the DNS thing for this TCP stack because it didn't have one at the time. It also didn't have DHCP, or it only had a very, I think it actually didn't have DHCP, it was just manual configuration, so I had to write the whole DHCP protocol as well, which is kind of fun. Then we create the socket, we set the callback, and we say this is our buffer for receive, and it's 2 kilobytes, as I said, and then we do the connection. And then we erase, okay, so this is erasing the screen. So we already cleared the memory up further up, so I should actually put that higher up here with all of this. And the reason for what this is doing is setting every second byte to a space, so that if nothing else has been loaded in into the screen RAM at any point, so if the scrolling for some reason is showing stuff that's beyond the bottom of the page, if the page isn't longer than one screenful, for example, then this will make sure that you don't see any junk in the bottom of the screen. So Tego's asking, is there a page size limit memory-wise? Yes. So the page has to fit into these regions that I've talked through. So it's a couple of hundred lines of 80-column text is what can be fit, and the graphics has to fit in 128 kilobytes because there's 2 banks of RAM free for the mental blank for the tiles. Now you could push that limit. We could reuse bits of this other area of memory as well to kind of get more space for that. And later on we could make it so that you can bank out the part of the ROM to free up another bank or so to fit more graphics on. But already actually you can have enough graphics to mostly fill a 640 by 400 screen, one screen's worth, more or less, because that's going to be, half of that roughly, because you can get 2,000 tiles into that 128k of RAM, and so that would be like it's half of an 80 by 50. Okay, so while it's trying to load the page, so again we wait until we're disconnected, we loop through, we do the task periodic, so that will call the network stuff, that will call the callbacks and cause everything to load. We update the mouse position so that again while the page is loading, the mouse remains responsive. If we've had an error code in the loading process, then we stop, and we also check if you press the R button, then we restart loading. If you press run stop, then we stop the page loading as well. And then finally we say okay, we're disconnecting, and we run the TCP engine for a little bit longer after we do the disconnect, so that there's actually time for the TCP teardown to happen, hopefully, just so that we can be a little bit nice. And then we fully release the TCP socket so that we don't burn through our limited number of sockets that we're still allowed to have, because the TCP stack is very limited in the number of sockets that you can have. Okay. Mouse color, so this is the 2 color sequences for the mouse. This assumes that the page, if it loads a palette, that it keeps the C64 palette in those first 16 entries, and the MD2H65 thing does that. So you've effectively got 240 colors available for images. In fact, actually 239 because of reasons. The update mouse position, so this is the thing that uses the standard C library that we've made for the mouse for 1351. That's already available, and we basically get that, and how did I do the that's right, so this is a little bit funny. This is how I'm doing the color cycling to choose the entry out of the those arrays. So they've got 8 colors in them each, so that I can actually just use 3 bits from a slow counter. And to do the counter, I'm using the VIC-4, well actually it's the CPU has a frame counter for how many frames have been displayed. And so we take that number, we divide it by 4, So every 4 frames it will change color. And whether we have a link currently under the mouse, we choose which of those 2 color sets to use for the mouse. So it's super simple link indication. If someone wants to make tooltip support for it, they're totally welcome to, but I'm not going to. We've got plenty of spare sprites. You could actually make a sprite tooltip that showed the URL if you wanted to get fancy. It would probably need Kixi to free up the space. But again, there's a bunch of those things that are kind of just really nice user experience things that are actually quite feasible for us to do, because we don't have to waste any memory on the whole rendering of the page. We're already 2/3 of the way through the entire browser in 15 minutes of explanation or something. So then we check the mouse position. If it's in the top border, then we scroll down by the appropriate amount and we walk the mouse to the top edge. Likewise, if it's at the bottom of the screen, we did the same thing there. So we're just scrolling to keep the mouse just on the screen. And then to do the I'm just trying to remember. Yes, right. Okay, so the do scroll is also it's a flag to say are we showing a page? If we're showing a page, then we want to check if we know the mouse position and we quantize that into the character cells that are displayed on the page. So again, the page is character cells. So if the mouse is up here and it's at 0, 0, and down here it's at X position, 0, Y position, not 199. The sprite is at 240 or something, but we've actually got in terms of the 50 rows of text of 8 pixels each, it's 400 pixels. So we work out where we are in that to the nearest character, so that we know which character we're in the Y and the X directions, so that we can then look up to see whether there's a bounding box that matches. If so, then we pull out the link, and that's what we use to do that indication. So again, we check that, so we get the number of bounding boxes by reading out the 2 bytes out of RAM. If it's more than 1,000, we say, well, actually, you probably don't. You shouldn't have more than 1,000 links on the page, partly because we have a pretty unintelligent brute force search through the list of the links, the bounding boxes rather, to see whether we're in any of those. And as soon as we're in one, we copy the address of the link out of memory from where it comes, and we stop. So mouse link address will be set to the ASCII string of the URL, and then finally, of course, we update the mouse pointer. So the show page routine, this gets called once we've loaded a page to display things. Okay, so Tager is asking, can the browser display all Petsky characters? Yes, it can. So if you don't supply a different font as part of the page, it will use the C64 character set ROM. So you could have pages that are Petsky rather than ASCII. So MD to H65 produces ASCII pages rather than Petsky pages. But that's just because that's what I cooked up, to do a demonstration with Markdown for that kind of thing. But it's totally doable to have Petsky pages rather than ASCII pages. And because we supply the color RAM, they can be full color Petsky, which is the other really, really nice thing with it as well. Okay, going back to the show page routine, skip over debug stuff I had in there. If we have an error, then we tell the person to press a key. But if the page loaded successfully, then we apply a bunch of those video mode settings that are contained in the page. And then we set the screen address to the specified location. The color RAM we set as well. Tell it to display 51 rows instead of 50, so we can do that smooth scrolling, as I said. And then we set the smooth scroll vertical position. And we initially say that the maximum screen offset, so this is used for working out how far down we can scroll, right? Is 0, and the max position, which is the maximum Y position from 0 that we can have, And if there's more than a screen full of stuff, so if there's more than 50 lines, then we work out what those can actually be. Otherwise, they stay 0. And that's it. That is the code that renders a page, because it gets shoved down as chip RAM. And then really we just have, so this is our default page that we're loading. And then we have the main routine that, so we obviously set 40 megahertz mode, we enable the Mega 65 hardware, seed our random number generator, initialize the Ethernet interface so that it can start doing the media negotiation first, because the Mega 65, when it powers up, the Ethernet interface is off, not on. So you have to turn it on in software, and then you have to allow, it takes a couple of seconds for the Ethernet negotiation to happen. And then so we want to do some initial mouse setup, and so it's actually quite nice the way we've made the mouse library. You can actually bind it to a sprite. So if you do mouse update pointer after you've bound it to a sprite, that sprite, so sprite 0, will physically track the mouse around the screen, and so you don't have to worry in your code about fiddling with that kind of thing. And you can set a bounding box to say where is the mouse cursor allowed to go. So we've set it to 24, which is the left edge of the screen with a normal border. We've allowed 20 pixels above the top border so that you can do that scrolling and have it walk back and do the scrolling. Likewise, the right border and the off a bit from the bottom of the screen so we can do the scrolling in that direction. Then we call the prepare network routine that we talked about before. We enable sprite 0, it should be not sprite 1, as the mouse pointer, and set the display for that. Probably actually should have done that up here ahead of that, but we do. And we tell it the sprite data comes from the cassette buffer, where we have a bit of space for that. And then we copy our sprite pointer data down there. Again, because CC65, well, maybe it does have a way to do it, but I'm not aware. You can't force the alignment of a structure in memory. If we could force the alignment of a structure in memory and force it to be in the bottom 16 kilobytes, we actually could have just set the sprite pointer to be the address there, and then save the cassette buffer for something else. Anyway, so then we simply load that initial page, we display it, just make sure that the mouse clicked status flag is cleared so that it doesn't just immediately click on, onto another page. And then we just have a infinite loop displaying the page, update the mouse position, including doing the scrolling, check for some keys, so you can actually use the cursor keys as well to scroll. We check for the reload page option. So that's cursor key for scrolling. And if the mouse is clicked, and if the mouse is over a link, we saw the code that worked out whether we were over a link before, because we have the address of the link under the mouse. We can copy that down because it's up in a higher bank, so we can't access it directly in CC65. We copy it into the URL, and then we chop the URL out to get the host name and all the bits and pieces that we need from that. So this supports both relative URLs and absolute URLs that have the HTTP and host name on the front. Again, it's a horribly simple little parser, but it works. And once we've got all that ready, we just fetch the page and show the page, and we continue in that loop. So that's it. That's all there is to the browser. It is, as I say, designed to be gobsmackingly simple in its construction. Just going to check. So I haven't actually tried the keyboard scrolling for a while since I did the mouse stuff. Yeah, so the keyboard is, as you can see, I'm just using the cursor keys. Oops. And that's just scrolling by a line at a time. Obviously, the mouse is faster, right? So that is a first look at, if you like, the first alpha of the browser for the Mega 65. It's currently just called Fetch because I can't think of a better name. I'd love to hear if anyone has a any nice ideas for a better name that can convince us to switch to it. And if anyone would like to work on the browser to make it nicer and more full-featured and things, that would also be totally welcome. I really just wanted to be able to make something to demonstrate a bit of what's possible, and probably I will add some support into it at some point for being able to download files. That was kind of the original goal, so that you could browse through a file list, and again we could have thumbnails on them and nice things as well, and then be able to to download files directly. So ROM files and core files and things are two in particular that would be great to be able to do that way, as well as just being able to download software directly onto the Mega 65 from the Mega 65. So as Tega has said, having the file host support this and have H65 pages on there, that would be fantastic to see. So yeah, otherwise really the next step for me to do will be to have it so you can actually press a key that lets you then type a URL in directly. That would be a really good thing to do, so that you can actually navigate wherever you want to. We could probably also squeeze out a little bit of RAM somewhere to have a little bit of browser history, so that you can navigate back to previous pages without having to type in the URL all over again. We could actually use the RAM at D triple, like under the I/O. There's the 4 kilobytes of RAM there, because we can use a DMA to copy stuff in and out from under there pretty easily. So we could actually have our browser history under there. But again, we have to try and optimize the size of the code in particular to have a chance to be able to fit anything much more in there. Glad that increasing the desire there for you, Amok, to get a Mega 65. And yeah, that's it for me. It's now very much my bedtime, so I'll crawl off to bed happy that I've finally squished enough bugs to get it working to this point, and look forward to seeing what we can do and start getting some content out there, because once we have the URL entry in there, there's really nothing stopping us putting the first version up on file host for people to grab, and then I'd love to see people chucking some pages up to play with. So yeah, that would be good. Okay, take care folks, and we'll see you around next time.